A variable rate loan is a type of financial arrangement where the interest rate fluctuates based on changes in an underlying benchmark, such as the prime rate. In this video, we'll explore how these fluctuations impact the total repayment amount of a loan. Let's take a look at an example. Natalie borrows $5,000 on April 7 at prime plus 1%. The prime rate was initially 3%. It increased to 3.25% on May 23rd and to 3.5% on July 13. What was the amount required to repay the loan on August 2nd? To calculate the total amount that Natalie must pay by August 2nd, we must recall an important formula, the simple interest formula, where we can find the interest, I, by multiplying the principal borrowed, P, by the rate, R, multiplied to the duration, T. From April 7 to May 23rd, the interest rate was prime plus 1. So we'll say that R is equal to 3% plus 1%, which amounts to 4% during that period. So let's find out how much interest Natalie had to pay just for that one period. Let's use the formula. I is equal to a principal amount of $5,000 multiplied to the rate of 0.04, which is 4% converted as a decimal. And between April 7 to May 23rd, if you take a look at this chart, April 27 happens to be the 117th day of the year. May 23rd is the 143rd day of the year. Taking their difference, we find that that amounts to 46 days. So we'll take 46 out of 365 days and use that as our value for t. Let's use our calculator. 5,000 multiplied to 0.04 multiplied to 46 over 365, and we end up with 25.205. Let's keep up to 3 decimal places. We do not want to round right away. So I'll write down 25.205. We'll round to 2 decimal places at the very end once we've computed everything we need. We're told in the question that on May 23rd, it increased to 3.25. And then there was another increase on July 13. So the next period is from May 23rd to July 13. This time the rate is 3.25% plus the 1%, which amounts to 4.25%. Using the chart as before, remember that May 23rd is the 143rd day, and July 13 is day 194 in the year. When we take their difference, we end up with 51 days apart. So this time t will be 51 over 365. Using the same formula as before, and with that new interest rate of 0.0425 multiplied now to 51 over 365, we end up with another interest amount. 5,000 multiplied to 0.0425 multiplied to 51 over 365. We end up with 29.691. And notice again that I'm not rounding this number at the moment. That will be done at the very end of our calculation. And for that last period, it goes from July 13 to August 2nd. And this time, there's another increase of 0.25%, which amounts to 4.5 total. Let's write that down. The rate is 4.5% this time altogether. And from July 13th to August 2nd, pulling up that chart, July 13th is the 194th day of the year, and August 2nd is day 214. Taking their difference, we have 20 days. Let's apply these to the formula one more time. 5,000 multiplied to 0.045, and that's being multiplied to 20 over 365. We end up with an interest of 12.328. To get the total, you must add up these interests along with the 5,000. So the number on our screen plus 25.205479 plus 29.291788 plus the 5,000 gives us a total of 5,067 and 23 cents, rounded to 2 decimal places. That is how much Natalie needs to owe from start to finish on this loan. If you would like to see a similar example to this, prepared underneath, simply leave a comment in the comment section below and I'll gladly upload a video of its solution. Talk to you all later.